Давайте начинать. Первый выступающий Ян Стоttko. Тема его доклада он сам сейчас озвучит, чтобы мне просто не отбивать работу ведущего.
Okay. First, my name is Jan Stottko. I'm the responsible sales manager for SMA solar technology for Russia. Next slide, please. I want to talk today about the topic why it makes sense to integrate photovoltaics in diesel generator systems, and I will present the technical solution for this. Why we talk about this? Quite simple. The price of diesel is increasing, and the system costs for PV, or the production cost of electrical energy with photovoltaic, decreased heavily in the last years. Next slide, please. Я могу сам, да? Хорошо. Of course, short introduction of SMA, then I will explain a little bit the business model, then the technical application, and why SMA or our references here in Russia. Our company is now more than 30 years old. We had last year a turnover of 1.5 billion euros. There are more than 30 gigawatts of our inverters installed in the world. We have in 21 countries sales and service companies. We are more than 5,000 people, and we have 1,000 engineers in our R&D department. We are making inverter solutions for all applications, on-grid, off-grid, which is quite interesting, I think, also for Yakutia. We make backup solutions. We have solutions for residential up to the industrial market. And we work with all PV panel technologies. This is a short overview about the product range for small inverters. This we are doing with big inverters. And here's some examples of some big installations in the world which you can find with our technology. Okay, coming to our topic. I think this everyone knows. Everyone who is really living here also in Yakutia and is involved in the off-grid systems here knows that even maybe the fuel price in Russia is small, but it's increasing. And we have additional transportation costs. If we are talking about diesel prices, we always say the fuel price plus the transport price. So if you generate from diesel electricity, you have heavily increasing prices of the production costs for the diesel generators. And at the same time, in the last 3 years, the production costs for electrical energy from photovoltaics decreased dramatically. We already have today, we are at the point that we can produce for cheaper money electrical energy with photovoltaics in comparing with diesel generator systems, and that's why I'm here today. I heard last days, yes, we were talking about solar potential, and mainly we are only focused, okay, how much is the insolation? So here you see there are more influence factors, or factors influence the cash flow of such a project or the rentability of such a project. This is of course the insolation. But additional, these are the on-site costs of the fuel, these are the effectivity of the diesel generators, these are for how much money I can build a PV station. So we have to consider much more factors in order to find out if a system makes sense. And I can say you also, we can build close to the North Pole a solar station. If the fuel cost there is 5 euros per liter, I'm sure that we can find out a rentable, or that it makes sense, it makes profit to produce solar energy there. This is a little bit now some graphs, and this is what I was explaining. You see something about payback times and the fuel, this depends on the fuel price for 1 liter of diesel and how it depends from the insolation. And yesterday I learned in Yakutia, close to Oymyakon, we produce 1,000 kilowatt hours per kilowatt peak. That's even 10% better in Germany. So there is a possibility that such kind of projects work. Also from the economical point of view. From technical point of view, this is absolutely no problem. How this solution looks like, what we like for the coupling of PV to diesel generator systems. I do not talk now about systems with batteries, I talk about systems without storage. We should have the daily load is significant, 24 hours, 7-day load. The load profile, the daily load profile, should as close as possible to the production profile of the solar energy. Usually I say, of course, the most what we like is this daily load profile. What is also good, of course, a quite constant profile. What is maybe not so good are these typical village supply profiles with morning and evening peak. But at the end, finally, you only can say it after simulation what does make sense or not. We need place for PV, but this is a minor problem in Russia, I think. We have every time place. The application should be bigger than 0.5 megawatt, we believe. And the fuel cost should be over $1 per liter, but I think this we have here. And of course, the people or the energy companies should want to save money. This is very important. We already did last year, or the company Safra did last year the first fuel safe project. They made the smallest solution which is possible. They just connect some PV to some diesel generators. You can do this approximately to 20%, because you have to avoid that the PV makes a feedback to the diesel generators, but if you have, for instance, a 100 kV generator, you can connect 20 kV solar energy without disturbances. So that's possible. If you want to connect more solar energy, you need a regulation system. And this we already have. We call it fuel safe controller. With this you can reach penetration levels up to 60%. That means to a 1 megawatt plant you will be able to connect 600, maybe 700 kV of solar station. And we ensure still that the generator is working without any problem. These two possibilities you already have today. And the next we are working on currently, the next step what we will go is that we want to reduce the spinning reserves of the diesel generator systems. I will show you later a little bit what it means. And then the last step will be that we have a real off-grid system, that we can switch off the diesel generator, and that this is done completely by solar energy and accumulators. How it looks like a little bit in reality, here's an example. It's a mining site, but it can be also a village or something other. Here you have the loads, here you have the genset. I know in Russia we are always inside, have the gensets inside. We have some control room. So the first step, what you can do, just adapt the solar station, up to 20%. We have the inverters and so on. If you want to make more, and here you see, I just want to show, you have to make them to communicate with each other. You have to make, you need to measure the loads, you need to communicate, or you have to measure the output of the gensets, and you need to influence the photovoltaic inverters. You need some data acquisition module, a computer at the end, a regulator, and some connection to the inverters via communication. This is the last step done, we already have in planning. This is the final step then when we bring this battery inverters inside. A lot of people asking me also today, okay, what is about battery technologies? We are working on for this kind of solutions. For small solutions, we have. This is the technical principle. You see the diesel generator. By the way, it can be also the weak grid. This is also possible. We have the solar inverters. We have some communication, and we have the loads. So how it works. This is on the right side. You see a typical load curve. We have it at 6 o'clock in the morning. The load is 100 kV, 6 o'clock in the morning. We have no sun, just the diesel generator works. I see a little bit problems with the graphics. We have it now around 8 o'clock. What we have to ensure in such a system is always we have to ensure that if the PV fall down because of a cloud or something, that there's always enough spinning reserve from the diesel gensets. And we have also to ensure that the diesel generators works in an area of good efficiency. So this should be over 30%. So currently here at this time we have approximately 800 kV load from this reserve. So we can say, okay, 560 kV could be covered by PV, this signal we are giving to the inverters. So, but currently only 200 kV are produced by D. So the other 600 kVs are coming from the disogens. Now we produce more energy. Now we produce 560 kV because it's now close to 10 o'clock. The disogens, this both, going now back down to 120 kV each because our load is still close. Now we have a problem because, or maybe a problem, the diesel generator may automatically switch all the load to one generator for more efficiency. So, but now we have the situation, if the PV would disappear, we have 800 kV load, and we have only one diesel generator with 400 kV. And if the PV disappear in this moment, the spinning reserve of the inverter is not big enough, the generator is not big enough. So what we are doing, this we measure, this is, and at the end we say then to the PV station, okay, please reduce your power, that we force the generator system to switch back to 2 disogens, that we have always the spinning reserve in case of the PV is not working anymore. Now it's coming a cloud. The PV is going down from 500 kV to 80. We think the smallest point is 10 kV. And this is regulated automatically because we have still the reserve. And so let's go on. Okay. So what we can do? We can reduce the cost of fuel. With this technology, we significantly reduce the fuel costs. We of course reduce also the CO2 emissions. That's nice. The solution is scalable. You can start with 20% and you can later increase the stuff. You are more independent, you have a higher planning security and so on. The last pictures, just what we are doing. We can make the simulations. We also make a cash flow simulation. This is no problem. And now some stuff, some references about this. I think the well-known station from Yailu now, which is equipped with Sunny Island system and batteries. This is not a real fuel-safe project. I think this is the first real fuel-safe project which I saw in Russia. This is the installation from Energo. This is a fuel-safe installation in South Africa. There the client will save approximately 400,000 liters of diesel per year. So you see they have approximately 2 megawatt of diesel gen cells and regrid, and they combine this with 1 megawatt of PV. And just to show you, this is not a new invention, what we are doing here. This is a fuel-safe project from Thailand, which we realized 8 years ago. And they approximately save every year 200,000 liters. Okay, this was, I hope, Спасибо за ваше внимание.